Welcome back to ArmanisMath. We are reviewing for the chapter test, or the topic test, topic 3, binomials, and polynomials, I should say. And we stopped here at binomial expansion using the Pascal triangle. So I'm going to do another example because some of you have asked for that. So one more example of Pascal. This one I'm gonna go with perhaps, let's say, x plus 3 to the 4th power. So I need somebody to look at their Pascal triangle and give me the 4th row, not the 0th row. Remember, the first thing is called the 0th row. Give me the 4th row, and it should start with 1 4 something. Could you look at that and give me that row? Look at your Pascal triangle and give me the 4th row. I see one person says 1 4 6 4 and 1. Okay, so I got this from Pascal. Let me confirm what I have here with the actual triangle that I constructed earlier. So I'm going to go here and see. What is 1 4? Here we go. The 4th row in Pascal. Remember, the first thing is called the 0th row. This is the 4th row. 1 4 6 4 1. 1 4 6 4 1. That is correct. Two things that I could actually double my assurance. The first thing is this is 4th, so I have to start with 1 4. Okay, which basically going to end up with the same numbers, 4 and 1. And the second item is, if it's 4, I'm going to end up with one more extra term. So 1, 2, 3, 4, 5 terms. Anyways, how do I do this? Well, Pascal tells me that you could do this by using brackets and borrow numbers from me. I'm going to lend you numbers. Pascal is saying, I'm going to lend you numbers. Okay, Pascal, thank you. That's kind of you. So I'm going to lend you 1. Okay, I'll take one from Pascal. And perhaps this one I'm going to use a different color, by the way. I'll use one from Pascal. So this is like that. That's the one. I'll use the one from Pascal. And then I'm going to take the term. So this is called my first term. First term. This is my second term. Second. This is my first term. I'll take my first term, which is x. Put that to the maximum possible exponent. Maximum, the highest, which is 4, times the second term, which is the 3, to the lowest possible. Well, lowest possible is not 1, because if you put 1, you're going to end up with 5, and 5 is much more than 4. So the lowest possible is 0 here. Okay, that's the first term when you end up with plus. By the way, there's no pluses and minuses here. You don't add or subtract within the bracket. You do it after the bracket or between the brackets. And then I start another bracket and borrow 1 from Pascal. Which terms I'm going to use? By the way, I usually like to do a check mark next to the one that I used. So I've used the 1 as a check mark. Now I'm going to use the 4. Help me out here. 4 times what? X to what power? X to what power? I need some feedback from you guys. Okay, so remember, if I start with 4th, I can't just keep I have to lose a power, and then the other item would, thank you, Johnny. So it's going to be actually 3. And then the 3 itself, the second term, will gain a power. Because they all have to add up. Both of these would have to add up to 4. They cannot exceed 4. So let's say by mistake I put 0 here again. Well, you got 3 plus 0, that's 3. Well, you have 4. You have to compensate for that. So that's not true. You got to go back here and put 1. Basically, 1 increases. I should say 1 decreases, and the other one increases. The power is, okay? The powers. And then close that. And then I just, again, have to make sure that I check next to the 4. That means I used it. Plus, I'm going to use the 6 from Pascal now. 6. And this time actually I'm going to check mark right next to it, right as soon as I use it. And then I'm going to take the x to what power? What do you think is the power here? Good job, Johnny. I need more than Johnny. I need more. Here we go. Second power. While the 3 is going to be to the what power? It has to be to the second. You're right. Because 2 plus 2 is going to give you 4. So that's another safety check for you. Good. All right. I'm going to come here and then use... I'm going to use... What do you think I'm going to use from Pascal? Which number am I going to borrow from Pascal now? I'm going to borrow the 4 from Pascal. And if I borrow the 4 from Pascal, just right next to it, just for my sanity, I'll put a check mark next to it, and then I'm going to use that. X raised to what power? Raise x to what power? Who else? Who else want to talk to me here? I'm gonna, if it's 2, then it has to lose a power. So it will be 1, as you guys said. And the other term, which is a 3, that's gonna gain another 1, which is gonna bring it to 3. What makes me sure that this is the right track? Well, again, the powers should add up to 4, not more than 4. And the last one, I'm gonna borrow 1 from Pascal, which means I borrowed 1 from Pascal, check mark next to it. And then I'm gonna take the x to the 0. That's okay. I'll leave myself a little bit more room here. And the 3 to the maximum possible power, which in this case is 4. Because 0 plus 4 is going to be just 4. All right. Let me go back here and shift back my attention to me just kind of cleaning things up a little bit here. Okay, just tidy up things here. So I've got 1 times 4. I've got 1 times x to the 4th power. X to the 4th power is x to the 4th. Well, that's not surprising. X to the 4th. 3 to the 0. How much is 3 to the 0? How much is 3 to the 0? It's 1. Anything to the 0 is 1, except itself, obviously. Plus, this one drops the way it is here. I've got 4 times 3 to the 1st. So 3 times 4, basically, that's 12. And I've got x cubed. Plus, I've got 6 times 3 to the 2nd power. 3 to the 2nd is what? What is 3 squared? What is 3 squared? And what is 9 times 6? What is 9 times 6? Come on, champions. 9 times 6. Hello? Anybody home? 54? Can somebody confirm? 54 of what? 54 of x squared. And then I got plus. I've got 4 times, this is 27. 3 to the 3rd is 27. Somebody find us what is 3 times, what is 27 times 4? What is 27 times 4? $108. Can somebody confirm? 27 times 4. 108. 108 x's, and then I have this dude here, which is x to the 0. That's the 1 times 1, and 3 to the 4th. What is 3 to the 4th? Oh my gosh. What's 3 to the 4th? Hello. 3 times 3 times 3 times 3. 9 times 9. IT1. So basically you're saying this is a 1 times plus times 81, which is just 81. So let me add a little bit to this here by asking you, which might be a test question, what is the third term in this polynomial? What's the third term? That's very true. The third term. So the third term is the whole thing. This is the whole thing. You grab the whole thing just like that. This is the third term. Okay? So third term actually for me is going to be positive 54x squared. Now, what is the coefficient of the fourth term? Coefficient of the fourth term. Yep, it is just that number. It's just the coefficient means just the number. Okay. Term means the whole thing. Well, you guys are doing good. I like that. So now I move on to this was a kind of a portion of that last section, and we're gonna move on to, believe it or not, here I come. We're gonna move on to this next section. Do ask me questions before I move on. Ask me questions before I move on to the next section. I see no questions. All right. So let's move on to the next section, and that is going to be 3-4. Basically, here is dividing. You're going to divide polynomials. And there's two types of division we've talked about. So somebody tell me actually. Can somebody tell me what exactly are we referring to here? There's two different divisions methods that we've used in this class. Can somebody tell me? Here's long division is one of them. That's very true. Long and synthetic. Thank you. Long and synthetic. Long and synthetic divisions are used to divide polynomials. So I'll take an example of each, okay? I'll take an example of each, and let's do, want us to divide long division. Or use long division to do x cubed minus 8x squared minus 5x minus 30 divided by x minus 9. Okay, x minus 9. For long division, this is it. This is you're kind of ready. First thing first, you have to put things in standard form. Is this in a standard form? What makes me think this is standard form is me looking exactly at the exponents. This is 3, this is 2, this is 1. How about x to the 0, Armani? Well, x to the 0 equals to 1. So if you want to be facetious about this, it's actually going to be here, 1 times 30. So actually it is in standard form, decreasing. We don't say it, but it's there. It's implied. So it is in standard form, and that means I'm ready. X minus 9 will be my divisor. X squared, x cubed I should say, x cubed minus 8x squared minus 5x minus 30 is the dividend, and the divisor is x minus 9. So I'm going to use again my tool here to do the work. And I like to do the work on the side, not to clutter things. So here I'm going to choose to divide. So I'll take the first term divided by the first term. X cubed divided by x, which is going to give you x squared. I'll put that right on top of x squared. It's kind of cosmetic. You could start from here or there, it doesn't matter. But it's very important that you do it correctly down here. So then you're going to take this and then multiply it back by your divisor. So x squared times x is x cubed. If you watch that video about synthetic and long division, you know that this exactly has to match. If it doesn't, that means you did something wrong and we have to fix it. And then x squared times the negative 9, that's negative 9x squared. And we said something, if you guys remember again in the video, that you subtract, right? You subtract the entire row, or as we said on 3, you do what? 1, 2, 3. What do you do here? Does anybody recall? From the class and the examples and the videos, you change the sign. Here we go. So on 3, you change the sign. Basically, you're doing like that. But some of us forget when you do like this, that the negative belongs to this x cubed and also to the 9. That's why we just said change the sign. It's easier to think of it that way. So on 3, you change the sign. And you know that you're on the right track if these two cancel. If these two cancel, you know that you're doing the right thing. If not, then you have to go back and fix stuff. Positive 9 minus 8, that's an x squared. That's 1x squared. These two guys drop. So we've got negative 5x, negative 30. Right? I will take the x squared, which is the first term, divided by the first term again. So x squared divided by x equals x. So I'm going to put the x here. And again, I'm going to just take that and do what I did with x squared, which is basically multiplying it backwards. So x times x is x squared. That's a negative 9x. And on 3, I do what? 1, 2, 3, I do what? I do change the sign. So I gotta change the sign. Negative and positive. These two will go bleep bleep, which is correct. 9 minus 5 is 4. 4x. Oops, that's a different color. 4x's. The negative 30 drops the way it is. Do the same process again. I've got 4x's divided by x. That's just going to be a 4. And I'm going to put the 4 right on top of the constant with the number. And guess what? You just have to multiply it back. Just like what you did with the other two items. So take that and multiply it back to the 9 and the x. So that's going to be 4x. And it's going to be, what is 4 times 9? 4 times 9 is how much? 36. And it's negative 36. On 3, I do what? On 3, I do what? What did we do on 3? 1, 2, and 3. Yo-yo. I change the sign. Don't be afraid. Change the sign. So this is going to go bye-bye, and this is going to leave me with 6 as the remainder. Remainder of this problem is 6. That's the R. That's the remainder. Okay? And the way you write this is going to be simple. You just have to look at your quotient. So you're going to start with the quotient here, which you're going to say equals to. Your answer is going to be equals to x squared plus x plus 4. Okay? Plus x plus 4. And then you're going to say plus the 6, that's the remainder, divided by whatever is your divisor, x minus 9. Also in your plus the 4. Also, in your textbook, you have another way to write this, which is interesting. In your textbook, they have also this. We could say or. You have x squared in parentheses as a factor, plus x plus 4 times x minus 9 plus the 6. Okay, that's another format to see your answer in. So this is in a nutshell long division. If you want more help, obviously watch that video on long divisions. A lot of you said that you benefit from these videos, so take advantage of that. They're free and they're thorough, and you could take advantage of that. This was a long division. Let me pursue this with with synthetic division. So let's use synthetic division. Okay, this is synthetic division. Synthetic division. Well, in this one, I'm going to use, also give you an example of that. So let's use one that is going to be very kind of helpful to us to see. So divide, obviously synthetic division. So divide x or p. This function is named p of x cubed minus 2x plus 1. You're going to divide this by x minus 2. Okay? So let's do that here. X minus 2. If I end up with 0 as a remainder, I'm lucky. It doesn't happen often, but I'm lucky if that is what goes on. First of all, is this in standard form? Standard form. Let me write this clearly, legible. Standard form. Is this in standard form? If it's not, help me out to put this one in standard form. If it's not, am I missing anything? Is there a standard form? Is this ready for me? Okay, not sure. Who else? Let me see some other feedback. I see some yeses, I see them not sure. Okay, so let me ask you the question in a different way. This is cubed, right? This is cubed. Do I have something else that is missing? Is there a power that is missing here? Aha, that is right. So it's not a standard form. To put this in standard form, I have to supply what's missing. So to put this guy in standard form, I got to say x cubed plus 0x squared minus 2x plus 1. So basically, I was missing this 0x squared here. I was missing 0x squared. You can do synthetic division or long division without actually fixing this first, at least for the method that we know here in this level. So you really have to compensate for what's missing. Now, before you also start, so standard form is one thing that you have to fix before you start if it's not there. And the second thing is to solve for the a. So take the x minus 2 and put that equal to 0. That's going to give you the a term. Basically, you're saying a minus 2 equals 0. And the a is going to equal to 2. This 2 is very important because that's the one that you're going to establish your synthetic division upon. So I'm going to have to put 2 here. So basically, I'm going to have to put 2. How did you get the 2? Well, whatever your divisor is, you have to set that equal to 0. That's going to give you the a term, which is going to be that term that you're using here, that number that you're using here. And basically now you just have to look only at the coefficients, not the variable, just the coefficients. So I'm looking here at the 1, I'm looking at the 0, I'm looking at -2, and I'm looking at 1. And as we said, if you guys remember, you leave yourself a room for a line that goes, okay? How does this help me? Well, you just divide it. Basically what you have to do now is just write the variables. So remember, you always start with 1 degree less. If you end up with 1 degree less than what you started with. So this is actually a 1, or you could just say x squared plus 2x plus 2, and then finally the 5 is divided by the divisor, which is x minus 2. Or another way we said, you could write it down as your textbook is suggesting, x2 plus 2x plus 2 in parentheses times the divisor, x minus 2, plus that remainder at the end of the problem. Okay, x squared. Any questions on this one? Any question on this one here? Good. All right. Move on to the last item, which is 2.5. 2.5 would be summed up in, I'm sorry, 3.5 is what I meant. 3.5 is summed up in one simple concept, and we're going to take a look at that right now. So 2.5 says basically you have zeros of polynomials, zeros of polynomials, zeros of polynomials. Zeros means solutions, by the way, right? Or x-intercepts. Solutions, x-intercepts. So luckily they gave us some graphs for this problem, and they said, what if I gave you something like this, and we give you a graph that looks like that? Let's do a graph here. 1 second. And then go up, and then go down, and a little blurb here, and then go down here, and go up. Okay, some graph like this, and they're saying this is a -2, -2. Please write this down, or if you want to wait until the video. This is also a something happening here. They said multiplicity of. I'm gonna pretend. I'm gonna just give you some. Let's say this is 1. Okay. This is 1, and this one is going to be 2 and 3. Okay, so these items, these two actually, these 3 different spots is where my function crosses, and what they're saying here is what is this function? The zeros is obviously the touching points, right? So I've got this one here, I've got this one here, and this one here. I don't need to pay attention here very quickly as I close. In a couple of minutes here. If you have multiplicity, that is, for example, if my function looks like this, I have x minus, in this case, plus 2, x plus 2 squared times x minus 1 to the 3rd degree, and x minus 3. Okay, watch this for a second. This power here, this 2 is even. Do you see that? If the power is even, multiplicity is even. What you're saying here is x plus 2 equals 0, right? X equals -2. At -2 here, I have a even power. Even power. When you have even power or multiplicity of 2, you could say that multiplicity of 2 in this case, you are not crossing the x-axis. You're just barely going to come and touch and leave. They call it math kissing the axis and leave. You're just barely coming to the -2 and touch and then leave. You're not going to go through it because of even power. Keep that in mind. Even power, you don't go through the axis. You just leave. If you want to put it here, the word kiss, just to remind you. You're kissing and leaving. At 1, however, because I have an odd power, let's look at this. At 1, I have an odd power. At 1, I have odd. So at 1, I have odd power, which is 3. I go through the graph goes through the x-axis. So it does go through the x-axis because multiplicity of 3, which means I have 3 solutions here repeated. It's multiplicity of 3. And because it's odd, I go through the x-axis. And I do whatever I have to, blah, 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 blah. And I'll come over here going up. And also here I go through because the power is odd. Look at this power here. This is an odd power because of that. X minus 3 to the first power. It's an odd power here. So this is odd. That means I go through. I don't just kiss and leave. That's basically in a nutshell what 5 is all about. You look at the graph and you identify your zeros, the solutions, and this will tell you how many of these are repeated. So I've got -2 repeated 2 times. I've got 1 repeated 3 times. This one is repeated 3 times. 3 times. Multiplicity of 3. And this here, this 1 is, I'm sorry, the 1 is repeated 3 times. Odd. 3 times. This is odd, but it's only 1 time. Only 1 time. For odds, you go through the axis. For even, you just barely kiss and leave. All right, this should conclude our review today. There's a couple videos. This is the second video, and both of them will be posted for you guys to review and do the assignment. Be blessed wherever you're at. Happy studying.